original theory of forces in 5 steps. First, analogy and the simplicity of nature, inspired by Newton as a general epistemological principle. Second, the principle of continuity, inspired by Leibniz as a concretization, and apply this general epistemological principle to the investigation in nature. The third is completely new step, the formation of continuous curve of force, so-called curva Boscovichiana, describing the acting of attractive and repulsive forces in nature. Fourth step was a model for the construction of larger particles from smaller, which was crowned with the fifth step, the final conclusion that matter is composed of indivisible and non-extending points that are in addition endowed with forces and separated from each other by some distance. In this moment, so in 1748, Boscovich's points of matter have 4 properties: indivisible, non-extended, endowed with forces, that mean attractive and repulsive forces, and separated by some distance. Later, after the objections, Boscovich added the 5th property, endowed by inertia, because there are many scholars who ask what with inertia, to assign to body or to assign to his points of matter. And finally, in Theoria, in 1758, he assigned inertia to his points of matter. This is the 2 first versions of Boscovich's curve of forces. In my opinion, it's very important figure 10, which connected Newton arc of gravity, of attractive force, with the novelty, with the arch of repulsive force produced by Boscovich, not whatever repulsive force, but infinitely potential infinite repulsive force at the infinitely small distances. It's very, very precisely defined. So it was the crucial moment for the emerging new theory of forces, Boscovich's theory of forces. Boscovich's research on the forces in nature first resulted in new understanding of force, and later in a new insight into the structure of matter. He was particularly proud of the elegant application of his core of forces to the study of 3 points of matter. The equilibrium states of such a system formed a system of confocal ellipsoids, the Boscovich model of atom of 1748. In order to construct a comprehensive system of natural philosophy, Boscovich had to examine the most difficult of all the metaphysical questions, that of the nature of space and time. In 1754, in 1755, in his supplements to Benedict Stuy's Philosophia Recensio, contemporary philosophy, it was epic on natural and on Newton's and Boscovich's natural philosophy. He shaped his original doctrine of space and time in two supplements, the spatio ab tempore and the spatio ab tempore ut a nobis cognoscuntur. In doing so, he further developed his understanding of human cognitive abilities in a conclusion. I think there is no way in which it is possible, without assumptions, directly through observation, to distinguish absolute from relative motion. It is also the point when Boscovich left Newton, or exactly Newton's conception of absolute space and time. His research in natural philosophy Boscovich crowned with the masterpiece Philosophia Naturalis Theoria. Here is the first page of autograph kept in a bankrupt library in California now, and this is the title page of the third edition, Theoria Philosophiae Naturalis, published in Venice in 1763. The work was written during the winter in Vienna in 1757 to 1758. In the first part, he argued against the objection which Giovan Battista Scarella, in his 3-tom work, Physica Generalis, submitted to his law of forces and his matter parts. Scarella's book was the first book who, in a special chapter, here presented the Boscovici systemata, made objections to Boscovich's natural philosophy, but not from scholastic position, but from Leibniz position. And it was so systematic, so that Boscovich, the last fourth part of his Theoria of Philosophia Naturalis, defended his views about the forces in nature and about the properties of his points of matter. In the second part of Theoria, Boscovich took his final position on Newton's laws of motion. He accepted the first law and the third law, and he didn't accept the second law of Newton. And in the third part, he aimed to apply his theory of forces to until then all known physical and chemical phenomena. With this work, he greatly influenced a generation of English and Scottish physicists and chemists, from Joseph Priestley. In 1772, I'm showing now for the chapter of Priestley History of Optics, which is devoted to the Boscovich's general hypothesis. It was named, Priestley's name for Boscovich's theory of forces.